Okay, the study guide for Test 2, Unit 6B. Alright, so we will be graphing this cube root graph. So the first thing we want to do is define our key point. And we get that from looking here. We ask ourselves, what number minus 2 equals 0? That would be positive 2. And then our back value is a 1. So we have 2, 1. From there, we want to go ahead and try to create a cube root of 1 and a cube root of 8. So what I mean by that is, if I have the equation up there, some number minus 2, plus 1, we're trying to make what's inside the radical equal 1. So if I use 3 minus 2, that's 1, that's the number I want to use. So now 3 minus 2 is 1, so now I have the cube root of 1. The cube root of 1 is 1, so 1 plus 1 is 2. So my coordinate is 3, 2, taking the number that would create the 1 and the number that we got at the end. So that's going to give us 3, 2. Now, since this is a cube root graph, we are going to need to mirror this new point we just made. So if we look at our center point, our key point here, if it is up 1 and then right 1, then there's another 1, down 1, and left 1. They should be diagonal of each other. All right, we're going to do the same thing with the cube root of 8. Some number minus 2 and plus 1. Once again, we're trying to create 8. So 10 minus 2 is 8. So that would work. So we would now have the cube root of 8 plus 1. The cube root of 8 is 2. And we add 1 to it, we get 3. So our point is 10, 3. So 10, 3 would be right here. Now we need to mirror that point. So if I'm going back to the center point right here, you can see it goes up 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8 to the right. So that means I'm going to go down 2 and 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And now that I have my points, I'm going to go ahead and draw the curve. All right. So now that we have our graph made, we can answer some more of our key features. So it asks for the x-intercept. That's where the graph touches the x-axis. It's happening right there at 1, 0. In behavior on the left side, so that means as x approaches negative infinity, we want to know what does the y approach. So as we look to the left, you can see the graph is pointing downwards. So it's going to head to negative infinity. If we're talking about the right end behavior, that means we're talking about positive infinity for the x. So we're talking about the right side, and that means you can see how the graph is kind of pointing upwards, so it's going to head to positive infinity. Okay, problem 2, we're doing more graphing, and we're doing a cube root. So once again, we want to find our key point by asking what number minus 2 would equal 0. It's going to be positive 2. Our back number is positive 3. So now we have our key point located here, 2, 3. All right, so the next thing we're going to do, we need to create a cube root of 1 and a cube root of 8. So we have negative 3, cube root of some number minus 2, then plus 3. Once again, we're trying to create the number 1 here. So what number take away 2 is equal to 1? That would be a 3. So we have negative 3, the cube root, 3 take away 2 is 1. And so the cube root of 1 is 1. But now we have this negative 3 in front. That's going to get multiplied to that 1. So negative 3 times 1 is negative 3, plus 3, that makes 0. So our coordinate here is 3, 0. So it will be right here. And that's on the x-axis, so that's our x-intercept. Now for our, we have to remember to mirror that point. So if this point is down 3 and right 1, the other one will be up 3 and left 1. Once again, they should always be diagonal to each other. All right, so now we're going to create the cube root of 8. So negative 3 cube root some number minus 2 equals 8. That number would be 10. So we have negative 3 cube root 8, because 10 take away 2 is 8. The cube root of 8 is 2, but we have this negative 3 in front, so it's going to get times together. So that makes negative 6. And then we get negative 3 here. So our coordinate is 10, negative 3. So 10, negative 3. Once again, we're going to mirror that point. So if that is 1, 2, starting from the center, 1, 2, 3, 4, 5, 6, 6 down, and 8 to the right, I'm going to go 6 up and 8 to the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And now I can go ahead and connect the points. So it looks something like this. Now this is asking us two other key features, which is the positive interval and the negative interval. So as a reminder, the positive interval is the section of the graph that is above the x-axis. So in this case, our graph right up here is above the x-axis. And so since this graph is heading towards the left forever, that means the lowest x value would be negative infinity. And it hits the x-axis at positive 3. Now once again, that line is on the x-axis at 3. That 3 is a neutral number. It's not part of the positive interval or the negative because it's on the x-axis. And so it's going to get a parentheses. And that means the negative interval starts at 3, once again using parentheses because it's essentially everything directly after 3. And then our negative interval is everything that is below the x-axis. And so since this graph is heading down forever, it's everything from 3 all the way to infinity. Now, the reason why it's infinity and not negative infinity, because we are describing in terms of the x-axis here. So since the graph is going right, it's using 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. That's why these are being described in terms of x. Okay, problem 3, we're going to be solving and checking for extraneous solutions. So the first thing you always want to do is to get the radical by itself. Now our problem, it currently is by itself. So that means we're going to start off by getting rid of the radical sign. And since the index is a 3, we're going to use its inverse, which is the exponent of 3, to eliminate the radical. That's going to leave us with 5x plus 3 equals, and then 7 to the third power is 343. Just going to solve for x, so we're going to minus the 3 over. So we have 340. Then we're going to divide by 5. So 340 divided by 5 is 68. And now we have to figure out, is this a solution or an extraneous solution? To do that, we're going to check it by plugging it back into the original equation. So we have the cube root of 5. Now instead of having an x, it will be 68. Wherever there's an x will turn into the answer that we got. And so now we're just going to do the math on the left side. 5 times 68 is 340 plus 3, 343 inside the cube root. And the cube root of 343, if you don't know how to do that in your calculator, you're going to hit the number 3. You're going to hit the second button. You're going to hit the caret button. That's going to bring this should be on your screen once you hit that. Once you have these symbols on your screen here, type in 343, hit enter, and it's going to tell you the answer is 7. And then we just see 7 is 7. So we know this makes sense, therefore 68 is going to be a solution, and we don't have any extraneous ones this time. All right, problem 4. Once again, solving and checking for extraneous. Once again, our goal here is to make sure that the radical is by itself before we get rid of it. So currently the radical is on the right side. There's nothing in front of it. There's nothing behind it. So it's isolated. So we can go ahead and remove it. This time we have a square root. There's the index of 2 there, which means we can use a square to remove the radical. So we're going to end up with x squared equals 18 plus 3x. Now, in this problem, since there's an x squared and an x value, that 3x, we want to move everything to the same side. I want to move everything to where the x squared is. I always want my x squared to be positive because I need to factor in this problem. So I'm going to minus the 3x over. I'm going to minus the 18 over. So I'm going to end up with x squared minus 3x minus 18 equals 0. Once again, when those all cancel out, you get a 0. So now I have a trinomial, which means I need to use my box to factor. So we have x squared, negative 18. We times them together to get negative 18x squared. And then we have negative 3x. So we have to figure out two numbers that would multiply to be negative 18, but if you added or subtracted them, you would get a negative 3. Negative 6x and 3x, I believe, works. So negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So now to get our factors, we know that x times x makes x squared. X times 3 makes 3x. X times negative 6 makes negative 6x. So now we have x minus 6, x plus 3 equals 0. This is where you can use your zero product property, or you can do this mentally in your head as you have probably done earlier in the year. I will show all the math for you, where we set it up to set each one equal to 0, and then we solve for x. However, we have to figure out if we have any extraneous or any solutions. Are they both solutions? Are they both extraneous? Is it one? We have to check. So we're going to go ahead and start off by checking x equals 6. All right, so wherever I have an x in the problem, I will replace it with a 6. All right, so once again, when it comes to checking, you are not moving anything around. You're simply doing the math that you see. So 3 times 6 is 18. 18 plus 18 is, I believe, 36. So we have the square root of 36, and the square root of 36 is 6. Since both sides are the same, 6 is 6. That makes sense. We know 6 is going to be a solution. We have to check to see if negative 3 is a solution as well. So now I'm going to go ahead and check x equals negative 3. So we got negative 3 equals square root 18 plus 3 times negative 3. So now we have 18 minus 9 inside the radical. And then 18 take away 9 is 9. The square root of 9 is 3. Negative 3 does not equal 3. So this one right here is going to be an extraneous solution. All right, solving once again. Once again, we want that radical to be isolated, and it is. So we have an index of 2 here, so we're going to square it. Those are going to divide away. So we're going to end up with negative 48 plus 14x equals x squared. Once again, we want everything on the same side when we have an x squared and an x, so we can factor. So I'm going to minus the 14x over. I'm going to add the 48 over. Those are going to subtract away. We'll end up with x squared minus 14x plus 48 equals 0, because since we are solving, we want our equation to equal 0. Then we're going to go ahead and factor. I'm going to do that right here. X squared, 48. We're going to times those two together to get 48x squared. And here, negative 14x. So I need two numbers that multiply to be 48, but would add to be negative 14. So they need to both be negative numbers. So negative 8x and negative 6x would work. Multiplying those two negative numbers together, we get positive 48. Adding those two negative numbers together gets us to negative 14. So finishing the factoring, x and x makes x squared. We'll get negative 6, and we'll get negative 8. So our factors will look like this. All right, and then using the zero product property, we set each one equal to 0. And then we In this case, we would add the 8 over, so x is equal to 8. Add the 6 over, so x is equal to 6. And once again, we do have to check to see if we have any extraneous. So we're going to check x equals 8 first. Once again, wherever you see an x, you're going to put an 8. All right, so 14 times 8 is 112, minus 48 is 64. The square of 64 is 8. 8 is 8, that makes sense. So I know this is a solution. Extraneous might be the next one, but we don't really know because we have to check. So we plug in square root negative 48 plus 14 times 6 equals 6. So 14 times 6 is 84. Take away 48 is 36. The square root of 36 is 6. And 6 is equal to 6. Hey, that works too. So they are both solutions. So we have solutions for 8 and 6. So there's no extraneous this time, so we don't have to put any numbers there. All right, so we're going to be graphing square roots. So when graphing a square root graph, we need to get the key point. So we ask ourselves, what number plus 4 is equal to 0? That would be negative 4. Our back number is a 2, so that will be our y value for our key point. And then we plot it. All right, so from here, we need to create a square root of 1 and a square root of 4. So if we have negative square root some number plus 4, and then plus 2. So we need to figure out some number plus 4 equals 1 in negative 3. Negative 3 plus 4 is 1. All right, so the square root of 1 is 1. Don't forget your negative sign that was in front. Plus 2. So negative 1 plus 2 is 1. So our coordinate is negative 3, comma 1. All right, since this is a square root, there's no mirroring of points. There's no mirroring of points when it comes to the square roots. Now we're going to do square root 4. So we have negative square root some number plus 4 plus 2. So we need to think of some number plus 4 equals 4. That sounds like 0. 0 plus 4 is 4. So we're going to have negative square root 4 plus 2. The square root of 4 is 2. Don't forget your negative sign in front. Negative 2 plus 2 is 0. So we had a 0, comma 0. And now to graph our square graph. We're going to start with the key point, and then we're going to draw a curve, always going to the right. All right, so doing some of our key features. One of the things I noticed is as for the y-intercept, I see that's our green point here at 0, 0. It wants the domain, which means we start with the smallest number and then write the largest number. So the smallest number of our graph is right here at negative 4. I'm using a bracket because negative 4 is one of the points on the graph. And it's moving towards the right. That means it's using negative 3, negative 2, positive 3, positive 7, positive 10 on the x-axis. So we're going all the way to infinity. Our range, once again, we are describing it from smallest number to biggest number. Since the graph is slowly heading downwards, it's slowly going down, the smallest y value would be negative infinity. Our largest y value is the 2, using a bracket. All right, another graphing a square root. So we need to find our key point. So we're asking the question, what number plus 9 equals 0? We'll be using negative 9, and then our back number is a 2. So negative 9, and then positive 2. There's our key point. All right, from there we need to create a square root of 1 and a square root of 4. So we have 2 square root something plus 9 plus 2. So we're trying to create, once again, we're trying to create a 1. So I think I need a negative 8 here. Negative 8 plus 9 is 1. That will work. So 2, we're going to get a 1 now, plus 2. So the square root of 1 is 1. Then we have the times 2. So that's 2 plus 2 is 4. So our coordinate is negative 8, comma 4. Once again, we're just taking this number up here for our x. So we're going to have the point right here. Okay, and then we're going to create a square root of 4. So we got to figure out some number plus 9 that would equal 4. Negative 5. So we'll have 2 square root 4 plus 2. The square root of 4 is 2. Don't forget your 2 that's in front. 2 times 2 is 4. That gives us 6. So now we have negative 5 comma 6. So right here, we start at our starting point, draw the curve, like so. This is asking for our y-intercept. I'm not sure exactly what it is. I think it might be 8, but since I need to find it, if I ever want a y-intercept, every y-intercept has 0 for x. So I'm just going to go over here and make my x a 0. And just do the math. So 0 plus 9 is 9. And so square root of 9 is 3. 3 times 2 is 6, plus 2 is 8. Yeah, so the y-intercept is definitely going to be right here at the number 8. So 0, comma 8. Our domain, once again, we're writing from smallest number to biggest number. Our smallest number is negative 9. Once again, it's going to the right, so it's using all these positive x's, so it's going to infinity. Our range, our smallest y value is right here at 2. The graph is pointing upwards, heading to infinity, and that's our range. Okay, so this is graphing. This is solved by graphing. And so we've done this before, but just to refresh how you read these problems here, it says use the graph to solve the equation. If necessary, estimate your answer to the nearest tenth. So you might have to ballpark 1 or 2 of them. But here for part A, this right here is representing this square root graph. Okay, that's the curve. That's what that part is representing. Okay. The number that it's equaling is representing a line that's horizontal at 1.5. So here is 1.5. That is a line going horizontally, like so. Your solution is the x value where they intersect. That's going to be this guy right here. So its x value is 1. You've now solved that equation without actually having to do any of the algebra. And you're going to do that for the other 3. All right. So our next one is equal to negative 1. So I'm going to go to negative 1 and draw a horizontal line. Okay, they intersect right here. That one is not quite at negative 2. It's a little bit less. I would maybe estimate negative 1.8 would be a good estimation for this problem. All right, our next one. We have this time equaling 0. Once again, horizontal line. It intersects right here at negative 1. Then we have our next one. Positive 3.8. So that's probably around here-ish. Drawing a horizontal line. I'm hitting this right here, and that's going to be at 6. Okay, solving and checking for extraneous solutions. So this one is one of the tough ones, okay? It's kind of tedious. There's a lot of work to do here. So step 1, always try to get your radical by itself. On the left side, it's by itself. So we're going to get rid of the radical by squaring. Now when we do this, this entire quantity on the right side gets squared. From here, we're going to have 2x plus 3, because these cancel each other out. And then we're going to do the shortcut mental math. Now, if you're not comfortable doing this, it's okay. You can use your box. It's totally fine. But let's do it mentally. We're going to have our x. It's going to get squared, so we have x squared. We're going to take our 2 and we're going to square it. That's going to give us positive 4. Now we need the middle term. So to do that, we are going to take the 2 and the x and we're going to multiply it together. And whatever you get, you need to double it. So I would get 4x. And we have multiplied that out using mental math. Now we're going to move everything to the same side so we can factor. So I'm going to minus the 2x over to where the 4x is. I'm going to minus the 3 over to where the 4 is. These are going to subtract away. So we're going to have x squared plus 2x plus 1 equals 0. Now we need to go ahead and we need to solve by factoring. So I'm going to make my box. We have x squared, a 1, a 2x, and then 1x squared. So I need two numbers that would multiply to be a 1, but would add to be 2. So 1x and 1x. All right, so once we factored, we're going to end up with x plus 1, x plus 1. Using your zero product property, we're going to find that our answers are x equals negative 1. Now the nice thing is both numbers are the same, so when we check one, we have checked both. So I'm going to go ahead and check x equals negative 1. Wherever I have an x in the problem, I will replace it with a negative 1. So on the left-hand side, I'm going to do that math first. I'm going to have negative 2 plus 3. That's going to give me a square root of 1. On the right-hand side, negative 1 plus 2 is 1. The square root of 1 is 1. That makes sense. So we have two solutions here. There is no extraneous in this problem. Everything is a solution. All right, number 9, we want to get the absolute value, not the absolute value. We want to get our radical by itself. So currently there's a minus x next to it, and we want to add it over. So we're going to have 5x minus 25 inside the square root equals x minus 5. From here, we're going to go ahead and square both sides to remove the radical. Once again, this entire quantity gets squared. We're going to end up with 5x minus 25 equals, and once again, this is where we can take our shortcut. We're going to take the x, we're going to square it, so we get x squared. We're going to take the 5, we're going to square it, so we get positive 25. Then we're going to take our two numbers, the negative 5 and the x, we're going to multiply them together, so we have negative 5x. Then we're going to double it to get negative 10x. Now we're going to move everything to the same side. So I'm going to minus the 5x over. I'm going to add the 25 over. So I'm going to have x squared minus 15x plus 50. And then here, this is where I'm going to go ahead and I'm going to factor x squared, 50, negative 15x, 50x squared. Okay, two numbers that would multiply to be 50, but adds to be negative 15x, is going to be negative 10x, negative 5x. So they'll multiply to make 50, but they will add to make negative 15. So x and x times negative 5, x times negative 10. So our factors are x minus 10, x minus 5 equals 0. Use your zero product property. And then you'll have x is equal to 10 and x is equal to 5. So here, once again, we have to check our answers to see if anything is extraneous. So we're going to check x equals positive 10. All right, so wherever there's an x, we're going to plug a 10 in. Okay, so 5 times 10 is 50. 50 take away 25 is 25. Square root of 25 is 5. 5 take away 10 is negative 5. And since both sides of the equation are the same, we know 10 is a solution. Now we need to check x equals positive 5. So square root 5 times 5 minus 25 minus 5 equals -5. So 5 times 5 is 25. Take away 25 is the square root of 0. The square root of 0 is 0. And so 0 take away 5 is -5 equals -5. That makes sense. This is also a solution. So this time we have solutions for both numbers. All right, we're going to be solving and checking for extraneous. So since both radicals are isolated on each side, we can square both sides. So we'll have 2x plus 16 equals -8 minus 2x. Pick one side for your x's to be on and your constants for the other. So I'm going to add 2x over to the left. We're going to have 4x plus 16 equals -8. We're then going to minus the 16 over. We're going to have 4x equals -24. Divide by 4. And we're going to have x equals -6. Have to check to see if it's extraneous. 2 times -6 plus 16 equals -8 minus 2 times -6. So here we're going to get -12 plus 16, that's square root 4, so that's a 2. On the other side, we will have -8 plus 12, that is square root 4, that is also 2. So it's the same on both sides, so we have ourselves a solution. All right, so for this problem, we're going to get rid of the radical by squaring both sides. And then we're going to have 12.5 squared is 156.25 equals 50 plus x squared. We're going to minus the 50 over. We'll have x squared equals 106.25 square root. X is going to equal roughly 10.3. Since we square root both sides, don't forget your plus and minus sign. This particular problem just says to solve. It does not ask us to check for any type of extraneous solutions, so we're going to leave it the way it is. We don't have to do any extra work on this one. Okay, so this problem is one of our review problems. It's there to kind of like challenge us a little bit and kind of refresh some of the stuff in the last test. So it's asking us to simplify the expression. And we write our answers as a simplified radical the best we can. So we're going to start off, we have a number in front of parentheses, so it means we're going to distribute. Remember, outside numbers are going to get multiplied together. Inside numbers get multiplied together. And then we're going to now do that to the next term in the parentheses. So we're going to multiply the outside numbers. We're going to multiply the inside numbers. Then we have our minus 12 square root x, 8x squared. Now we need to start simplifying our radicals to see if anything would be able to be added after we do that. So 18 is 9 times 2, which has a pair of 3 and 3. It has an x squared, so there's 2 x's. There's another pair. So outside of the radical, I'm going to have a 20, a times 3, and an x. And then I have square root, and then I just have a 2 left over. Now I have my next one. 3 is as small as it gets. I can't make that any smaller, but I do have 4 x's. That means I can make 2 circles. So I'm going to have an 8x squared, and then I have the square root of 3. For the next one, I have 8, that's 2 times 4, and 4 is 2 and 2, so I have a pair. I have 2 x's, so I have a circle there. So I have negative 12, a 2 comes out, and an x comes out, and then I'm left with the square root of 2, because a 2 didn't get circled. Going to clean this up a little bit. We now are going to have 20 times 3, that's 60x square root 2. Then we have 8x squared square root 3, negative 24x square root 2. So now I'm looking to see if I have anything with like terms. So this is x square root 2, this is x square root 2. Those are like terms, so I can combine them. So 60 minus 24 is 36. So I have 36x square root 2 plus 8x squared square root 3. And here we have an even index with an odd exponent on that radical, so I'm putting absolute value signs. That's as good as that gets. Okay, last question on the study guide. Okay, once again, a review problem from our last test. So we're going to simplify this. So inside the radical, we have a 64 getting divided by 2. So 64 divided by 2 is 32. And then we're subtracting, we have x 8 minus 2, y 5 minus 1, and then z to the 9th. All right, so we are going to have 32, x to the 6th, y to the 4th, z to the 9th. Now we want to simplify. So we're going to have 4 times 8, 4 times 2, 2 and 2, 2 and 2. And once again, anything that you have broken down is no longer there. We're going to circle our pairs. We have 6 x's. So 1, 2, 3. 4 y's. 1, 2. 9 z's. So 1, 2, 3, 4. All right, so outside the radical, I'm going to have 2 times 2. I'll have 3 x's, so x to the 3rd, 2 y's, and 4 z's. Inside the radical, I had a 2 that couldn't be circled, and I had a z that couldn't be circled. So that's going to give me 4x to the 3rd, y to the 2nd, z to the 4th, square root 2z. Once again, since I have an even index and I have an odd exponent on the x, I'm going to put absolute value signs on that problem.